So, in today's class, we are going to talk about laws of sines and cosines. And have you heard about it before? Have you come across this before?
The laws of pi?
Laws of sine and cosine.
No.
No? Okay. Then that makes me super happy that I'm going to teach you something new. Alright? So, what does the law of sine and cosine say? Let me put that and then we will kind of deliberate that. Let's see how much we can cover today and the rest we will cover in the next class. So far when we were talking about trigonometry, we started with right angle triangle. Okay? That you have to have a right angle triangle, then you apply Pythagorean theorem, then you apply SUKATOA to find out the relationship. Now trigonometry is taking the next leap of faith. It's saying it is not restricted to only right angle triangle. We know that it is not restricted to right angle triangle because we saw a unit circle also where we talked about angles more than 90 degree, correct? And we dealt with that. Now this is saying, okay, fine, you can apply law of sines and cosines to any triangle. Any triangle, regardless of whether it's a right angle triangle or not. You pick any triangle and you can apply laws of sines and cosines. So let me not confuse you by drawing too many triangles. Let me pick one stupid looking triangle which is not a right angle triangle. Okay? And let's say this angle is, let's say, alpha, this is beta, and this is gamma. Okay, I'm just giving three names which will add up to 180 degree. And then the angle opposite to alpha, the side opposite to the angle alpha, let's say that is A. Angle opposite to beta is B. And the angle opposite to gamma is C. So law of sine, we are talking about law of sine right now. This tells us how do you relate the angles and the sides. And the relationship is represented like this. So pick up sine alpha, the first angle. Sine of alpha divided by the side opposite to that, which is A, equals sine of beta opposite to that divided by side opposite to that, that is B, equals sine of gamma divided by the side opposite to that. So law of sine says that the sine of the angle and the side opposite to that are in the same proportion. Now let's think about it. Okay, it's not about just memorizing it just because the teacher is saying something. The law of sine says that when you have a triangle, any triangle, right angle triangle or not a right angle triangle, doesn't matter, this proportion follows, this ratio follows, meaning take the angle, take the sine of it and the side opposite to that. The ratio of these two will be same as the next pair of the sine of the angle and the side opposite to that. Will be equal to the next pair of angle and the next angle sine of that divided by the side opposite to that. Okay, and let's wrap our head around this to understand why and how this helps. This tells you that okay, every angle and the side of a triangle have certain relationship. That's what this represents. Now look at a situation like, okay, if you know these two sides and one of the angle, you can find out the next angle also. If you know these two angles and this side, you can find out this side. Yeah. If you know two sides and one angle, you can find rest of the side and rest of the angles also. Correct? Using this formula. Yeah. And this concept. But why it is to be believed? Right? How should we believe that this statement or this formula, this law, whatever we call it, is true? So let's check it out. We will first prove this And then, see, once we prove this and we are convinced that this law is correct, then applying this would not be a big deal. Correct? So, let's pick a triangle. I'm randomly picking a triangle. I'm saying that this is not 90, okay? Is it visible to you or it's not? I can make it a little darker if that helps. Okay, I hope this is visible now. Better?
Yeah.
So let's say this is alpha, this is beta, and this is gamma. This side is A, side opposite to alpha is A, side opposite to beta is B, and side opposite to this is, side opposite to gamma is C. Now, we know that this is not a right angle triangle. So, I am picking up this corner, this vertex, and from there I am dropping a perpendicular. Okay. So, let's give it a name. This is PQR was my earlier triangle. And when I dropped a perpendicular from this point to this point, to the next opposite line, this is meeting at, let's say, point S. So right now we have two triangles, two right angle triangles, PQS and triangle QRS. Is that okay? I took a triangle, from this vertex I have got the perpendicular. So this has split into two right angle triangles now. This is one right angle triangle, this is another right angle triangle. Okay? Now, in this PQS, let's say this beta, this angle is beta. So sine of beta by the Soka-Tua rule will be what? The side opposite to this, QS, divided by the hypotenuse. Correct? In this triangle, sine of beta will be side opposite to this, which is QS, the perpendicular that I have drawn, divided by C. Okay? So from this we got QS equals C times sine of beta. So far okay?
Yeah.
Now let's take this triangle, and from this is my angle gamma. So sine of gamma will be equal to what? Side opposite to this divided by hypotenuse. So QS divided by B. So QS from this one is equal to B times sine of gamma. Yeah. So this QS and this QS are the same, this side. That means C times sine of beta equals B times sine of gamma. Okay. So move C to this side and move B to this side. It becomes sine of beta divided by B equals sine of gamma divided by C. Yeah. So sine of beta divided by B equals sine of gamma divided by C. Make sense? And we can again extend this. We can pick this angle also. In that case we'll have to drop a perpendicular here and then do that. Okay. So I'm not going that far, but at least part of the triangle, part of the sine law we saw is worth believing now. Correct? So we are generalizing this and saying that from this we learned and we can appreciate that the law of sine holds enough water to be believed. Yeah. So now if you look at again, you will not have to prove this formula anywhere, right? You guys are not supposed to prove this formula in any of your tests. But why we are proving it? just to make sure that we're not learning it as a thing to memorize. We are learning it as a concept that we agree to, appreciate, and we have complete background of why and from where this formula came into existence. So now we are generalizing this and say, okay, if I have a triangle where angles are alpha, beta, and the names could be anything that you can think of. Okay, I just could think of alpha, beta, and gamma. That's why I'm giving them a name. You can give A, B, C. You can give Davik, Arus, and Sahit as names. Doesn't matter. So side up that is A, side up this is B, side up this is C. So law of sine says sine of alpha divided by A equals sine of beta divided by the opposite side B equals sine of gamma divided by opposite side C. This becomes our law of sine. And again, there's one more thing, okay? If you, there's a very practical relevance of this one that you would want to appreciate. If you have a triangle, any triangle, so visually you can see that this angle is the biggest of all the three angles that we have on the board right now, correct? In this triangle, this is the biggest angle, correct? This is smaller than that. This is smallest of the three. And this angle and the side have a direct relationship. See, if this is the biggest angle, the side opposite to that is the biggest of the three sides.
Yeah.
If this is the medium size angle, the side opposite to that is the medium size between the three sides. Yeah. If this is the smallest angle, then the side opposite to that is the smallest of the three sides.
Yeah.
So that is exactly what gets represented in the form of the law of sine, if you look at it. Right? Because sine is always the angle, the side opposite to the angle, basically. It relates to that. Correct? Sine theta is the opposite angle divided by hypotenuse. Sine theta is equal to opposite side divided by hypotenuse. Correct? So that relationship is given a more formal definition, by using the law of sine. Yeah? Relatable? Digestible?
Yeah.
Okay. Okay. Now, next one is law of cosine. So we saw law of sine. Let's see what is law of cosine. This is law of sine. Law of cosine. Law of cosine says that if you have a triangle, any triangle, and you have angles, let's say this angle I'm giving a name theta. The sides are, let's say, A, B, and C. Okay? In this case, you know two of the angles. Okay, let me not jumble things. This one we know. Now we are coming to law of cosine. Law of cosine tells you that if you know two sides and the angle between them, you can find the third side. How? This is based on this relationship. It says, let's say, you know these two sides and the angle between them. This is the third side. You can find out this third side, regardless whether this is right angle triangle or not. This is for any triangle. It says the side that is not known is equal to the square of the side that is not known is equal to the square of two sides minus 2 times multiplication of the two known sides and the cos theta between them. Okay? So this says if you have these two sides known and the angle between them known, you can find out the length of the third side using this one.
Okay.
So c square equals to a square plus b square minus 2 times the square, 2 times a and b, the two known sides, and the cos of the theta between the two sides.
Okay.
And again,
Is it multiplied by the cos?
yeah, it is multiplied by the cos theta.
Okay.
And I'll be dry honest with you, okay? I mean, mostly when I try explaining the concepts, I mean, whenever I come to any formula that I want to teach you guys, I look at how those formulas are derived, okay? And then I explain that before I come to this. This one, I thought, okay, we may not get enough time to talk about this, but I think we are going in a sequence where we are first learning what the law is, and then how that is derived, and then we'll do some problems. So this one I have not looked at how to derive it, but I will give it a shot, okay, because it's all based on concept, right? Let's look at it. So we will try proving law of cosine, and I'm being super honest with you, okay? I have not even looked at how they prove it, okay? I will just try proving it on the fly. And let's see if I still remember things that I learned for myself 35 years ago, okay? Let's look at it. So this is my triangle. This is, let's say, A, this is B, and this is C, and this angle is theta. Okay? And the law of cosine says C squared equal to A squared plus B squared minus 2AB cos of theta. Alright. And if I get stuck somewhere, then I explain that in the next class with Vedansi also being there. But let's give it a try. Now, again, right now there is no relationship. When I look at this square thing, right, my first thing that comes to my mind is it might have something to do with the Pythagorean theorem. Yeah?
Yeah, the square.
Yeah. Let's drop a perpendicular.
I think I see the word square because a squared plus b squared
Equal to C squared.
minus 2ab.
Yeah. So that's what I'm saying. So I will probably borrow help from Pythagorean theorem to see how true this law of cosine is. Okay. So we have a triangle here. Let's give it a name P. Let's say PQR, and where it's dropping a perpendicular, I'll give it a name S. And this side is let us B. Okay. Now, okay, all right. Let's look at it. So, in this right angle triangle, what is the value of cos theta? Cos theta will be equal to this length QS divided by A. Okay. And if this is theta, this will be how much? 90 degree minus theta. Yeah. All right. Correct?
Yeah.
Okay. Okay. Yeah. We'll probably, okay. I'm just scrambling right now to figure out how do I prove this, but let's look at it. So cos theta equals, okay. Yeah. Let's try putting it here now. So A squared plus B squared minus 2 times A times B, see, B times cos theta. Cos theta is equal to QS divided by A. So this A and this A we can knock off. So we are left with this whole thing is equal to A squared plus B squared minus 2B into QS. So B into QS. Now, okay. let me see if I have a shortcut for this one. Okay, let me give it a shot with with a shortcut and see if that is enough. Otherwise, I'll just re-look at this approach. Okay, this time I will use sine here ABC. Okay, this is, let's say this angle is this one, so opposite to C. Okay, and this angle is here. It's, let's say, this angle is capital A, this angle is capital B, because it's opposite to B. Now, if I use this, we know from this one, law of sine, we already know, sine of A divided by A will be equal to sine of B divided by this B. So, and will be equal to sine of theta divided by C. Okay. Now let's look at these two combinations. A sine B equal to B sine A. So, or A will be equal to sine of A by sine of B times B, and B. Okay, so let's put it here. A, in place of A, I will put this whole thing. So it becomes sine square A by sine square B times B square plus B remains B minus 2 into A. I will replace A with a B into sine of A by sine of B. This is my A times B. What am I getting? So I am getting B square times this thing, and this becomes 2B square. Oh, this is, so this becomes B square minus, so this is B square sine square A by sine square B, and this becomes, okay. Okay, no, this is not helping. This is certainly not helping. B square, this. Okay, B square, so this whole thing, this is B times, okay. No, this is not helping, okay. I'll find out the right way to solve it, okay. So for now, let's keep it in the back pocket. I'll prove that in the next class, okay. I can find out what is the easier way to find it out, okay. If I struggle with this for next 30 minutes, I can find it out, but we'll come back to this, okay, in the next class. I will prove how that law of cosine formula is derived, okay. I thought I will not get time to talk about it, but we do have time, but we'll come to that in the next class, okay. So far what we have done is we have seen what is the law of sine and what is law of cosine, and then we looked at how the law of sine is derived. We saw how that is derived. This one I am parking for the next class. I will explain that to you guys in a simpler, easier way, rather than me doing all the adventure on the board right now and then trying to prove it, okay?
Yeah.
Now let's go to solve some problems and see where this law of sine and cosine is actually used for solving or for applying that in the real concepts that will come across. So I'm just going to put, two laws that we have learned, law of sine, law of cosine. Law of sine says sine of A divided by A, that is a theta, the angle that you have in question, divided by the side opposite to that, equal to the second angle, sine of that divided by second side, which is the side opposite to that angle, equal to third angle, sine of that angle divided by the side opposite to that. And then law of cosine says a side that is not known to us, the square of that side will be equal to the other two sides, the square of the sum of the other two sides, minus 2 times these two known sides and the cos of the theta between them. Okay. So I'm just deleting them for now, and then we will look at the problem and see how do we solve it. So let's look at some legitimate problems that you guys will come across in your, when you're dealing with them. So we have a triangle here. Okay, A, B, C. This angle is given to us as 29 degree. This side is given as 18 and this side is given as 9. It says find angle B, which is given as obtuse. This angle is given as obtuse. Round to the nearest degree. Find the measurement of this angle B. So you only know this angle is 29 degree. This side is 18, this side is 9. We have been asked to find out the measure of this angle B from this information. How we can find it out?
So we're gonna find G, right?
This one. This is B, angle B.
Oh, okay. Well, using the side one, we know that B over 18 is equal to.
This is not G. This is not G. This is 9. Number 9.
Oh. Okay. Using this side.
Right. So let's look at this. Sine of this. Sine of 29 divided by the side opposite to that, which is 9, equals now this side and this angle. So we know this side and we have to relate to this angle. So sine of this angle, let's say this is x. Sine of this angle divided by 80. Yeah. So sine of 29 close to sine 30. I mean, we have been asked to find to the nearest decimal, 10th decimal place. Sine of, how does sine of 29 work? Sine of 30 is how much? Do you remember?
Sine
30?
30. I don't remember. Is it? I don't remember the exact number. Sine.
Half. It's half. So if you remember the table, right? So this is, see, this will probably come out handy. Sine, cos, 10, 0, 30, 45, 60 and 90. These are the most commonly used angles. Okay. Sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. You just have to remember the sequence. Okay. And we have proved that in the previous classes, but I'm just telling you, I mean, you would not want to prove it again during the exam. But 0, half, 1 by root 2, root 3 by 2, 1. And then when it comes to cos, the whole thing reverses. So start from cos 0 equal to 1, cos 30 is root 3 by 2, 1 by root 2, 1 by 2, 1. 0. And sine over cos is 10. So if you remember the sequence 0, half, 1 by root 2, root 3 by 2 and 1, that should be enough. Okay? And then sine by cos will be 10 and all that. Okay? So if you remember one line, everything else you can figure out. So since we are talking about 29, you can see value of sine is increasing gradually, right? So 30 is half. 29 will be probably a little less than that, maybe 0.48. I'm just making it up, okay? Alright?
Okay.
Or keep it half, 0.5 for now. So sine of x is equal to what? 18 goes up, 18 by 9 into sine 29. Sine 30 is half, so put half. It will be little less than that. Okay? Little less than that.
Okay.
So it becomes 9 into 18 and 18. It's approximately 1, but not 1, because you're not talking about 30 degree, you're talking about 29 degree. Yeah?
Okay. Yeah.
So your sine of x, sine of this angle is equal to 1, approximately 1, not 90. If you find any answer 89 or 88, that will be enough. Yeah?
Yeah.
See, the problem here is, if you're dealing with this kind of a situation, okay, the obvious temptation would be, okay, the sides and the angles are in the same proportion. So this angle, side upward to that is 9, and the side upward to this one is 18. Oh, this will be just double of it, because they are in the same proportion. But no, it will not be that way. You have to apply sine. So your obvious response would be, oh, this is 9, this is 18, side upward to 29 is 9, so side upward to 18 will be, the angle upward to 18 will be just double of it. You will say, okay, 29 times 2, 58, or maybe 59, but that is not the thing. It is closer to 90, yeah? So that is the thing that I was saying. Let me, okay, yeah. It says round to the nearest degree. So you can say, yeah, approximately 89 degree. Okay? And that will be fine. Now, let's look at the next problem. This time I will try being on mute as much as I can. Now I am talkative, I don't stop, but I will still let you think about it. So this is the next question. The following figure shows ABC with the side length to the nearest tenth. Okay. Let me first draw it. This is the triangle that we have. I'm saying A and writing B. A, B and C. This is given as 16. This is given as 39. This is given as 42. Okay. Find BC. You have this angle and this angle known to you, this side known to you. You have been asked to find out the length of this side, BC. Give it a try.
Okay.
Round to the nearest tenth. Okay, that's what. Okay.
And we want to find the side of.
So this side is 16. This side here to here is 16. This angle is 39.
Yeah, I saw that.
This is 42. You have to find out this side, BC.
Oh, okay.
Give it a try.
have sine of b, and sine of b over 16 is equal to sine of 42 over cb. But then, and then sine of 34, or no, that's 39 is equal to AB. But then from here, where do I go from here with?
See, so that is a little bit of tweaking you have to do. See, what we know from the law of sine is angle this up and this side up into that, angle this side up into this, angle this side up into this. Now since you know this angle and this angle, you can always determine this angle, isn't it?
Yeah.
So 180 minus this plus this, you get this angle. Now you only worry about the angles and the side pairs that you are concerned about. Okay?
Okay. And then when rounding, that's sine of 99. So then just go down to 90 there, or?
Yeah, I mean, it gives you sine of 99.
Yeah, sine of 99.
So sine of 99, again, you have to apply a little bit of unit circle thing here, right? So let's say we are talking about sine of 99. So 90 is here. 99 will be somewhere here. Meaning after 90, when you increase, your y coordinate value is decreasing gradually, correct? So if sine of 90 is 1, sine of 99, which is after 9 degrees, would have come down a little bit. So you can probably round it to, because if you go to this one, 65, meaning if you reduce by 30 degree, then you are reducing from 1 to root 3 by 2. Root 3 is 1.732 if I am not wrong. Divide by 2 gives you 0.8, 2 8 is 16, and 1 3 2 6 is 12, 0.866. So if you would have gone to 30 degrees below, meaning 90 plus 30, then you would have been at 0.866. But we are not there. So it's so 1 to 0.866. You need a 30 degree range, but you are decreasing by only 1/3. So you are decreasing by how much? Probably 0.14, 113 for a 30 degree. So for 10 degree, you are probably decreasing by maybe 0.05. I mean, just rounding it. So it will not be 1, it will be 0.95 maybe.
Okay.
Hmm?
And then now I found out that sin of 99 over 16 is equal to sine of 42 over CB. So do I just cross multiply it and get the answer?
Okay, yeah, that's it.
Okay. I got it. I just need to practice on the table more. I'm learning
Okay.
signs.
All right. Okay. Let's look at one more problem. I just while I was waiting for you to finish this, I kind of found out how to derive the law of cosine, but we'll do that in the next class. Okay. It's not that big a deal. It's an easy one. But let's look at some more problems. And see, while these questions are not very difficult, but there are a lot of things we have to put together. See, as soon as we came to 99 degree, our hands are tied by the time we reach sine 90 degree with SOHCAHTOA, with this table that you are seeing. But if I am going to 99 or 125, this is handy, right? Because unit circle tells us, okay, if I'm talking about cos, I'm going the negative side. If I'm talking about sine, my y value is gradually decreasing when I'm increasing the angle, correct? My y coordinate, which is sine theta, in the unit circle, that is decreasing. How much? That you are kind of extrapolating or interpolating based on what we know, correct? So all these concepts are coming together. They are complementing each other, right?
Yeah.
So let's go to the next problem. We have been asked to we'll try solving some law of cosine problem also. And all these theorems or the proof of the formula that we do, right? You have to always think, okay, how do I get to that in the shortest way, okay? So whatever I was doing, that was probably taking a longer route. I would have probably proved it in half an hour, but there's an easier way to find it out, okay? So just I was just glancing through it and I found it. But anyways, we'll do that with Vedanshi in the class in the next week, okay? But let's look at this one. We are given this triangle. This angle is given as 61 degree. This side is given as 16. This is B, this is A, and this is C. It says find AB, find this side. Or this is 5. We only know this angle, is it 61 degree? Yeah, 61 degree. This angle is given to us, these two sides are given to us, we have been asked to find out this side. So this is where you will have to think that, okay, if I know, okay, let's not try going to law of cosine. I mean, while I am tempted to say that you will apply law of cosine because you have two sides known to you and the angles between known to you, so you can find out the third side using the law of cosine formula. But I am saying, before we jump onto that, what would go in our mind from a approach point of view? Okay, if I know law of sine says this angle this side, this angle this side. So I do only one angle. So this angle this side, this angle this side. I don't know this, I don't know this angle either. That will not work. Let's look at this guy. This angle, sorry, this side, this angle is also not known. So basically, if I look at the law of sine approach, law of sine, we can get angle side, angle side, angle side. We know two sides. This angle, I can apply law of sine to find out this angle, right? So I can apply this, this side and this side known. So side applied to this one is this one, and angle applied to this one is this one, and angle applied to this one is this one. Okay, so here we have a problem. Both the sides that is both the sides that is known to us, the angles applied to that are not known. Yeah. So law of sine we cannot apply, right? There are one equation with two unknowns. How will you solve? If I pick this angle, this side is not known. So it's a situation where we have two unknowns with every approach, every combination of law of sine that we use, right? That's why law of cosine is actually helpful. Yeah. So I mean, again, let's break it down. Let's say we are hell bent on using law of sine, okay? Let's give it a name. This is alpha and let's give this name as a beta. Okay, let's force ourselves to use law of sine for solving this. Okay, so let's say sine 61, and this is not known, we'll give the name x. So sine of 61 by x will be equal to sine of alpha divided by 16 will be equal to sine of beta divided by 5. Okay? Yeah? And remember, alpha, beta and x, these are three unknowns. Okay? Yeah? And we are still trying to insist ourselves that no, we will use law of sine only. This combination. What do? We have x unknown, alpha unknown. Nothing that we can do. Correct? Look at this combination. Again, alpha and beta both unknown. What will we do? We'll just get the ratio. Right? That doesn't help. If we take these two combinations also, x is unknown, beta is unknown. You cannot solve an equation with two variables, right? Two unknowns. Correct? One equation not enough to solve with two unknowns. So that is why we have no other choice but to look for an alternate solution. That is where law of cosine says, okay, if you have an angle known to you and the two sides that is making that angle, then you can find the third side. So x squared will be equal to the two squared, sum of the squares of the two sides. So 5 squared plus 16 squared minus 2 times sides, the two sides, into cos of the angle made between the two known sides. Cos of 61 degree. Yeah. So see again, it's just not about say, okay, we know this formula, apply this formula. We have to, in any situation, exam-like situation, when we put our brain to work or put our brain to task, we have to make sure that, see, if we would have taken law of sine approach, we would have probably spent 2 minutes, 3 minutes to realize that, okay, this is not working. And that is why we are trying to differentiate between which path to follow. Law of sine or law of cosine. Right? So that's why we are deliberating right now to convince or to make ourselves agree to one approach that will work, and then we saw, yeah, this works. At least hereafter, after spending so much time deliberating about sine, law of sine, insisting ourselves to use law of sine, we realize that, okay, whenever you have a situation where you have two sides known to you and the angle between them known to you, you don't really have to go to law of sine. You have a ready-made solution for this one. Because in that case, law of sine will not work, because every combination you take, you are having one equation with two unknowns that you cannot solve. Yeah? Yeah? Alright. So this is, and then you obviously cos 61 is nothing but close to cos 60. Cos 60 is half. You can find it out. Correct? See again, cos 60 is half and cos 90 is 0. So you are decreasing. Okay? So it will not be exactly half, it will be a little less than that. So you can do with half and you will say, okay, it is approximately that value, kind of thing. Yeah? So I'm stopping here. I'm curious to know if whatever we talked about, did that make some sense? Did we learn something? Yeah?
Yeah.
And just giving you a clue with respect to what I saw with the law of cosine, okay? We have started the same approach. If this is A, this is B, and this is theta. We have to just drop a perpendicular, break this into two right angle triangles, find out the length of A square from here, B square from this triangle, and then relate that with this height. That will solve, okay? We'll do that in next class, okay? Let's not rush for it. It's just about finding some interesting stuff that we deal with to solve a problem. Okay. So what I would request Arush is go to Khan Academy on pre-calculus. Try doing the unit test on law of sine and law of cosine. Deal with some problems by yourself. Okay, because we saw some of them. Try solving it when you are not having a teacher around and see how you are able to tackle those problems. I'm not saying that whatever we did in the class that is magical in nature, but at least a jump start. So if when you try solving it and if you get stuck somewhere, that is what we'll come to and talk about in the next class, apart from solving the law of cosine, apart from proving how the law of cosine came into existence. Yeah? Alright? So with that being said, I will let you go. You are the only child. So 1 hour is actually a lot more for one kid alone. So I hope we learn something. Let's try applying it. It's not just about learning a lot and then not retaining it. So let's try solving few problems relating to these concepts, law of sine and cosine, and then we will continue with our journey. Yeah? Alright, have fun. Yeah.
Okay.
Are you coming to the class in the afternoon today?
Today?
Yeah?
Yeah, I should.
Okay.
Unless something comes up last minute.
Okay. See you in the class then. Alright?
Okay,
Yeah.
bye.
Yeah. Bye-bye.